Whatever we thought we knew about the beginning of the universe, we were wrong. We built the most powerful time machine in human history, the James Webb Space Telescope, to look back at the first light. We expected to see faint, messy, baby galaxies struggling to form. We expected darkness. We expected silence. Instead, we found monsters. We found galaxies so bright, so massive, and so mature that they defy the laws of physics as we understand them. They shouldn't be there. According to every simulation, every textbook, and every theory of the Big Bang, the universe at that age should have been a dark, foggy void. But today, the news has just broken. This isn't just another distant smudge. This is the new king, the most distant object ever seen by human eyes. A galaxy that existed only 280 million years after the Big Bang. They call it MOM-Z14, and it is terrifyingly bright. It is so bright that it makes no sense. It contains chemicals that shouldn't exist yet. It is clearing the cosmic fog faster than it should. Today, we are going to dive deep into this breaking discovery from January 2026. We are going to look at why this galaxy is breaking the standard model of cosmology. We are going to talk about supermassive stars, stars 10,000 times the mass of the Sun, that might be the only explanation. And we are going to ask the big question: did the universe start differently than we thought? This is the story of the impossible galaxy at the dawn of time. If you love uncovering the mysteries of the deep cosmos, peering into the void, and challenging the impossible, make sure to hit that subscribe button and turn on notifications. We are tracking the discoveries that are rewriting our history. Now, let's travel back 13.5 billion years. To understand why this discovery is keeping astronomers awake at night, we first need to understand what we thought we knew about the beginning. Picture this. The Big Bang erupts, a fireball of pure energy. Then, darkness falls. For hundreds of millions of years, the universe becomes a thick, opaque fog of neutral hydrogen gas. No stars, no light, just invisible gravity, slowly pulling matter together in the void. Eventually, the first stars ignite. Population 3 stars. Massive, blue, burning hotter than anything we see today. These titans blast UV radiation into the surrounding fog, carving out bubbles of clear space. This is the cosmic dawn. Slowly, over eons, more stars turn on. The bubbles expand and merge. The hydrogen fog burns away. The universe becomes transparent. This is reionization. And finally, after billions of years, galaxies like the Milky Way emerge. Mature spirals, slowly rotating, peacefully forming stars. That was the textbook story. A slow, patient process. That was the story. That was the timeline. We thought the first galaxies would be tiny, feeble. We thought finding them would be like trying to spot a firefly on the moon from Earth. But then, we launched the James Webb Space Telescope, and almost immediately, Webb started finding fireflies that looked more like searchlights. It started with JADES-GS-Z14-0, then others. But this week, the team led by Rohan Naidu at MIT and Pascal Oesch of the University of Geneva dropped the bombshell. They pointed Webb at a patch of sky and found a redshift of 14.44. Let's pause on that number. Redshift, or Z, is how we measure distance and time. The higher the number, the older the object. A redshift of 14.44 means the light from this galaxy has been traveling for roughly 13.5 billion years. We are seeing it as it was just 280 million years after the Big Bang. 280 million years. In cosmic terms, that is a blink of an eye. If the universe was a 100-year-old human, this galaxy existed when the human was about 2 days old. And yet, MOM-Z14 is not a baby. The paper, published in the Open Journal of Astrophysics, describes it vividly. It is luminous. It is massive. It is compact. Jacob Shen, a researcher at MIT, put it bluntly. There is a growing chasm between theory and observation. That is a polite scientific way of saying, we have no idea how this got here. Let's talk about the brightness. Based on our best computer simulations, galaxies at this epoch should be small clumps of gas with a few stars. They should be dim. MOM-Z14 is roughly 100 times brighter than predicted. Imagine you walk into a nursery expecting to find sleeping babies. Instead, you find a fully grown linebacker lifting weights. That is the scale of the anomaly. For a galaxy to be this bright, this early, it needs to have a lot of stars. Billions of stars. But gravity takes time to work. You can't just snap your fingers and turn a cloud of gas into a billion stars in 280 million years. The gas has to cool. It has to collapse. It has to fragment. The stars have to ignite. The sheer mass of stars required to create this much light is pushing the limits of how fast matter can flow. It's like trying to fill a bathtub with a fire hose, but the drain is open. There is a physical limit to how fast you can build a galaxy. MOM-Z14 seems to have ignored that speed limit, and that forces us to ask two possibilities. Option A, our understanding of gravity and galaxy formation is wrong. Maybe dark matter clumps together faster than we thought. Maybe the early universe was lumpier than our theories say. Option B, these aren't normal stars. Be prepared, because this is where the story gets incredibly strange. The light from MOM-Z14 isn't just bright. It has a weird flavor. When astronomers break the light down into a spectrum, a rainbow, they see fingerprints of chemical elements. In the very early universe, we expect to see hydrogen and helium. That's it. Those were the only elements made in the Big Bang. Heavier elements, carbon, oxygen, nitrogen, iron, are made inside stars. They are the ash of nuclear fusion. To get a lot of nitrogen, you usually need multiple generations of stars. First-generation stars burn fuel, die, explode, and scatter some heavy elements. Second-generation stars scoop that up, burn it, make heavier stuff, and die. It takes time. It's a recycling process. But when the team looked at the spectrum of MOM-Z14, they found a shocking amount of nitrogen. Nitrogen is special. In our modern universe, nitrogen is often produced by intermediate mass stars over hundreds of millions of years. MOM-Z14 doesn't have hundreds of millions of years. It barely has 280 million years total history. So how is it full of nitrogen? Rohan Naidu and his team have proposed a radical theory, a theory that sounds like science fiction. They suggest that the stars inside this galaxy are not like the sun. They are not even like the big blue stars we see today. They might be supermassive stars. We aren't talking about stars 10 times or 100 times the mass of the sun. We are talking about stars 10,000 times the mass of the sun. Monsters of pure hydrogen. Titanic balls of gas that live fast and die young. These stars would be so dense and hot that their cores would be nuclear furnaces on overdrive. They wouldn't burn for billions of years. They would burn for maybe 1,000,000 years, or less. And because of the insane pressure and temperature, they would churn through the CNO cycle, carbon, nitrogen, oxygen cycle, at a furious rate, pumping out nitrogen like a factory. If MOM-Z14 is powered by these supermassive stars, it explains the brightness. A star 10,000 times the mass of the sun isn't just 10,000 times brighter. Brightness scales exponentially. A supermassive star could be millions of times brighter than the sun. You wouldn't need a whole galaxy of normal stars to create the light we see. You would just need a cluster of these monsters. This changes everything. It means the dawn of time, wasn't a slow sunrise. It was a violent, explosive era dominated by stellar giants that make our modern stars look like candles. But the nitrogen isn't the only clue. We need to talk about the fog. I mentioned earlier that the universe was filled with neutral hydrogen. This fog blocks light. Specifically, it blocks UV light. For us to see MOM-Z14, its light had to travel through this fog. But something interesting is happening around the galaxy. The data suggests that MOM-Z14 sits inside a bubble of clear space. It has seemingly blown a hole in the fog. This process is called reionization. High-energy photons from the stars smash into the hydrogen atoms in the deep space fog, knocking off their electrons. This turns the opaque fog into transparent plasma. Astronomers have been fighting for decades to figure out when this happened. Did it happen at 500 million years? 800 million? MOM-Z14 shows us that it was already happening at 280 million years. And it shows us what was doing it. It wasn't quasars, black holes. It likely wasn't faint dwarf galaxies. It was these hyper-bright, nitrogen-rich monster galaxies. They acted like cosmic blowtorches, carving out bubbles of transparency in the dark universe. As more of these galaxies formed, the bubbles grew. They merged. And eventually, the whole universe became clear. We, viewing the cosmos today, owe our view to these early giants. Let's step back and look at the legacy of discovery mentioned by NASA. This isn't just one lucky find. It's a trend. Before Webb, the Hubble Space Telescope found GN-Z11, which was about 400 million years after the Big Bang. That was the record holder for years. It was already uncomfortably bright. Then Webb launched. It found galaxies at Z equals 12, Z equals 13. Then JD's GSZ140 took the crown. Now MOM-Z14 at Z equals 14.44. Every time we push deeper, we find more structure, not less. Pascal Wesch from the University of Geneva noted that confirming these distances with spectroscopy is crucial. Photometry, just taking pictures, can be tricked. Dusty galaxies can look red and distant when they are actually seemingly close. But spectroscopy is the DNA test. It reveals the redshift directly. MOM-Z14 has been confirmed with Webb's NIR spec instrument. There is no doubt about its distance. The fact that we are finding so many of these bright galaxies implies that the early universe was far more efficient at making stars than the modern universe. In the modern Milky Way, star formation is slow. Gas clouds hang around for ages. In the early universe, it seems like gas collapsed recklessly. It was a starburst mode on a universal scale. Why? Maybe the gas was denser. Maybe the lack of heavy elements allowed massive clumps to collapse without fragmenting. Or maybe there is something we are missing about dark matter. Some theories, like fuzzy dark matter or self-interacting dark matter, predict different early universe behaviors. Or maybe it links back to primordial black holes, as some other controversial theories suggest, that black holes seeded the formation of these galaxies much earlier than gravity alone could. While the current NASA paper focuses on stars, the whisper of new physics is always in the background when observations deviate this far from predictions. But here's where it gets visual. What does this look like? NASA released an image, a field of darkness, dotted with tiny jewels of light. MOM-Z14 appears as a blurry red dot. To our eyes, it's a dot. But in reality, it is a chaotic, swirling mess of gas and blinding light, perhaps similar to the Tarantula Nebula, but on the scale of a whole galaxy. It is small, much smaller than the Milky Way. Compact is the word Yijia Li from Penn State used, but its energy density is off the charts. Imagine the Milky Way's brightness squeezed into a tiny pocket. If you lived on a planet inside MOM-Z14, which you couldn't because planets need heavy elements like silicon and iron which haven't been made yet, the sky would be blindingly white. You would be surrounded by titanic blue and white stars. The radiation would be lethal. It is a hostile, violent cradle of creation. Why MOM? The name comes from the survey or the specific catalog, but it feels appropriate. Mother, a matriarch galaxy, one of the ancestors of everything we see today. We are looking at our own history, the carbon in your cells, the oxygen in your lungs, the nitrogen in your DNA. The atoms, or at least the seeds of them, began their journey in forges like this one. We mentioned the archaeology aspect. Rohan Naidu compared looking at old stars in the Milky Way to fossils. Some stars in our own galaxy are extremely old. They have strange chemical compositions. High nitrogen, low iron. We used to wonder where they came from. Now we know. They might be the refugees from galaxies like MOM-Z14. When we look at MOM-Z14 with Webb, we are seeing the factory where those weird ancient stars were made. We are seeing the fossil record being written in real time. And this is just the beginning. The researchers are already looking ahead to the Nancy Grace Roman Space Telescope. Webb is like a sniper rifle. It has a narrow field of view. It looks deep, but at a tiny patch of sky. Roman is like a wide-angle lens. It will survey huge areas of the sky with the same clarity. If Webb found a few dozen of these impossible galaxies, Roman might find thousands. We will move from anecdotes to statistics. Right now, MOM-Z14 is a celebrity. It's an outlier. But soon, we might realize it wasn't an outlier at all. We might realize it was normal for the early universe. And if it was normal, then the standard model of cosmology is definitely broken. We will have to rewrite the timeline of the first billion years. We might have to accept that the universe switched on almost instantly after the Big Bang, rather than waking up slowly. Let's dig a bit deeper into the broken theory aspect, because that is the most exciting part for us science lovers. The standard model is called lambda CDM, cold dark matter plus dark energy. It is very successful at explaining the cosmic microwave background, the afterglow of the Big Bang, and the large-scale web of galaxies today. But it has a middle problem. It predicts a slow, hierarchical growth. Small clumps merge to make medium clumps, which merge to make big galaxies. MOM-Z14 is like finding a teenager when the model says you should only find toddlers. To fix this, theorists are scrambling. Some suggest top-heavy initial mass function. This means that in the early universe, stars were just naturally bigger. Today, for every massive star, the universe makes hundreds of tiny dwarf stars. Maybe back then, the universe only made massive stars. Why? Because the gas was hotter? Because there was no dust to cool it down? If the initial mass function was different, it changes how we interpret everything. It changes how we measure mass. It changes how we calculate the age of galaxies. It's a knob that tweaks the whole machine. Other theorists go further. They suggest early dark energy, a burst of extra energy in the early universe that accelerated structure formation, or modifications to gravity itself. Finding MOM-Z14 is like finding a loose thread in a sweater. You pull it, and the whole arm might come off. It challenges the fundamental parameters of our reality. And let's not forget the human element. Imagine the team. Naidu, Wesh, and their colleagues. They get the data download from the Deep Space Network. They run the processing pipeline. The image appears. They run the spectroscopy. The line on the graph spikes at 14.44. Disbelief. Check the calibration. Is it a glitch? Is it a brown dwarf star in our own galaxy fooling us? They check again. The nitrogen lines are there. The break in the spectrum, the Lyman break, is there. It's real. The feeling of looking at a number on a screen and realizing you are the first humans to ever see this far back. It's a form of time travel. This is why we do astronomy. Not just for the pretty pictures, but for that moment of connection with the absolute origin. What happens next? Webb is still healthy. It has fuel for years. They will point it at MOM-Z14 again. They will stare at it for longer. They want to see if they can detect oxygen, carbon, maybe even hints of a black hole accretion disk, though the current data favors stars. They want to hunt for its neighbors. Is it alone? Or is it part of a protocluster? A city of galaxies just beginning to build the downtown core. And crucially, they will hunt for Z equals 15. Z equals 16. Is there a limit? Will we eventually hit the dark wall? The moment before the first star? Or will we find that stars were forming even closer to the Big Bang? The closer we get to the Big Bang, the more mysterious the physics becomes. We are pushing the boundaries of the observable universe. Whatever we thought we knew about the beginning of the universe, we were wrong. We built the most powerful time machine in human history, the James Webb Space Telescope, to look back at the first light. We expected to see faint, messy, baby galaxies struggling to form. We expected darkness. We expected silence. Instead, we found monsters. We found galaxies so bright, so massive, and so mature that they defy the laws of physics as we understand them. They shouldn't be there. According to every simulation, every textbook, and every theory of the Big Bang, the universe at that age should have been a dark, foggy void. But today, the news has just broken. This isn't just another distant smudge. This is the new king, the most distant object ever seen by human eyes. A galaxy that existed only 280 million years after the Big Bang. They call it MOM-Z14, and it is terrifyingly bright. It is so bright that it makes no sense. It contains chemicals that shouldn't exist yet. It is clearing the cosmic fog faster than it should. Today, we are going to dive deep into this breaking discovery from January 2026. We are going to look at why this galaxy is breaking the standard model of cosmology. We are going to talk about supermassive stars, stars 10,000 times the mass of the Sun, that might be the only explanation. And we are going to ask the big question: did the universe start differently than we thought? This is the story of the impossible galaxy at the dawn of time. If you love uncovering the mysteries of the deep cosmos, peering into the void, and challenging the impossible, make sure to hit that subscribe button and turn on notifications. We are tracking the discoveries that are rewriting our history. Now, let's travel back 13.5 billion years. To understand why this discovery is keeping astronomers awake at night, we first need to understand what we thought we knew about the beginning. Picture this. Let's put this all together. Webb just confirmed the most distant galaxy ever detected. MOM-Z14 at redshift 14.44. Just 280 million years after the Big Bang. An era that was supposed to be dark and empty. But this galaxy is 100 times brighter than it should be. It's packed with nitrogen that shouldn't exist yet. It's powered by stars we've never seen in the modern universe. Supermassive monsters 10,000 times heavier than our Sun. And it's not alone. It's one of many. These galaxies carved out the cosmic fog. They made the universe transparent. They turned on the lights. The textbook timeline? Wrong. The slow, patient birth of galaxies? Wrong. The early universe didn't whisper into existence. It exploded. We are living in the golden age of discovery. Every month, the rules change. The universe is bigger, stranger, and more violent than we ever imagined. As we look at MOM-Z14, we are looking at the torchbearer, the first light in the dark room. And it turns out, the torch was a flamethrower. I want to hear your thoughts. What do you think is powering this monster galaxy? Is it supermassive stars? Or is it something even wilder? Maybe a cluster of primordial black holes? And how does it make you feel to know that thousands of researchers were wrong about the darkness of the early universe? Let me know in the comments below. The best theories might get pinned. If you enjoyed this journey to the edge of time, please destroy that like button, just like Webb is destroying our old theories. And if you haven't already, subscribe and join our community of explorers. The universe has a lot more secrets to tell, and we are going to be here for every single one of them. For more details, I've linked the NASA article and the research paper in the description. Go out there, look up at the stars, and remember, we are seeing the light of the past, but the future of discovery is just beginning. Stay curious. See you next time.